Hello my dear friends, welcome to my YouTube channel. Myself Dattu Patel, Assistant Professor from LJIT. Earlier lecture we are already discussed about the change of variables from the other coordinates by the Jacobian method or a transformation method. Today's session we are going to discuss about the change of variables from the Cartesian to polar coordinates. Let's see. Firstly, the double integral can be changed from the Cartesian coordinate means xy to the polar coordinate means r theta by putting the x equal to r cos theta and y equal to r sin theta. Then our double integral f of xy dx dy equal to double integral f of r cos theta r sin theta mod j dr d theta means whenever we have to convert the Cartesian to polar coordinates, then for that transformation we have the formula dx dy equal to mod j dr d theta, where j indicated by the Jacobian. Then firstly we have to find the Jacobian. For that we have the x equal to r cos theta and y equal to r sin theta. That is a relation between Cartesian to polar coordinates. Then partial derivative of x with respect to r and theta and partial derivative of y with respect to r and theta, substituting in Jacobian and then finding the values of Jacobian, where Jacobian j equal to del of xy upon del of r theta. The indeterminant del x by del r, del x by del theta, del y by del r, del y by del theta. Then partial derivative of x with respect to r, that is cos theta. Partial derivative of x with respect to theta, that is minus r sin theta. Partial derivative of y with respect to r and theta, that is sin theta and r cos theta. Now expand this determinant, then that will give you r cos square theta minus minus plus r sin square theta, r which is common, then inside the bracket cos square theta plus sin square theta. You all are aware about the values of cos square plus sin square, that is 1. Then our Jacobian will be r, means values of j, that is r. That means dx dy equal to r dr d theta. Then whenever we replace or we convert Cartesian to polar coordinates, then dx dy which is replaced by the r dr d theta and x which is replaced by the r cos theta and y will be replaced by the r sin theta, means our function in form of Cartesian coordinates that should be also convert in polar coordinates, means function also convert in form of r and theta. For that we have to replace x as a r cos theta and y as a r sin theta and dx dy as a r dr theta and x square plus y square equal to r square. Then substituting the x as a r square cos square theta plus r square sin square theta, r square which is common, then cos square plus sin square, that is 1, that is values of r square. This value will be replaced in our functions and function which is converted in form of polar coordinate. Then after we solve the double integral. Now double integral f of xy dx dy equal to double integral function in form of r and theta, then function of r cos theta comma r sin theta mod j which is replaced by r, that is r dr d theta. Let's see one more example. Evaluate integral 0 to a, integral 0 to square root of a square minus x square plus y square dy dx. Firstly, inner limit which is y, means this limit which is indicated by the y, and outer limit which is indicated by the x, means x which is varies from 0 to a and y which is varies from 0 to square root of a square minus x square. Now we have to changing into the polar coordinates, means our question in form of Cartesian sum, Cartesian coordinates convert into the polar, means r and theta. Then for that firstly x which is varies from 0 to a and y which is varies from 0 to square root of a square minus a square. Here simplified this term, means squaring both sides, then our term becomes y square equal to a square plus x square. This x square comes this side, that will give you x square plus y square equal to a square. You know about the x square plus y square equal to r square, or that is the equation of circle x square plus y square equal to r square, that is equation of circle which has center 0 0. Then comparing this with the standard formula of circle, that is x minus h whole square plus y minus k whole square equal to r square. Then here values of h and k, that is 0 which is our center, and r square equal to a square, then radius which is a, then radius r equal to a. Now that is the equations of circle which has center 0 0 and radius. Let's see first plotting the graph. Here we have the equations which is equations of the straight line, that is y equal to 0, which is lies on the x axis, this one, then x equal to 0, that is lies on y axis, that is our equations, and this one is simplified this term, that will give you x square plus y square equal to a square, that is the equation of circle. Then this one is a circle, and according to the limit y which is varies from 0 to y equal to square root of a square minus x square, that is the vertical strip which is parallel to y axis, and according to this region we can say that our circle having only consider the first quadrant. Now converting to this in form of polar coordinates, then whenever we applying the limit in form of polar coordinates, then we taken the elementary radius vector which is this, here position O and this position will be A, that is our elementary radius vector or a transverse strip, that is in form of angular, which is starting from always origin. Then at this position values of r, that is 0, and at this position our boundaries will be touching to the circle, that is the radius A, then r which is varies from 0 to A. Then according to this region, whenever the we movement to the angular movement of the transverse strip in first quadrant, then this is touches to the initial line which is theta equal to 0 to the whenever we movement in upside, then maximum touches to the y axis, that is our 90 degree angle will be 90 degree. Then our theta which is varies from 0 to pi by 2, that is the limit of theta which is 0 to pi by 2. Now substituting this all limits to the our functions or double integral, then our double integral will be becomes in form of polar. The polar form of the given integral is I equal to double integral 0 to a 0 to square root of a square minus x square x plus y square dx dy. In this equation we replace dx dy as a r dr d theta, because we have the formula dx dy equal to mod j dr d theta, and values of Jacobian for the polar coordinates, that is r, then substituting r, then dx dy which is replaced as r dr d theta, and you all are aware about the x equal to r cos theta, y equal to r sin theta, then x square plus y square equal to r square. This substitute this value in this equation for the converting the polar form. Here we have the limit where r which is varies from 0 to a and theta which is varies from 0 to pi by 2. Firstly always we integral with respect to r, then after with respect to theta in polar coordinates. Then here x plus y square which is replaced by r square, dx dy which is replaced by r dr d theta, then r square into r, that is r cube, and integral of r cube with respect to r, that is r raised to 4 by 4, where r which is varies from 0 to a. Now upper limit minus lower limit, then it will give you a raised to 4 by 4 minus 0, then a raised to 4 by 4 which is common comes out, then integral where theta varies from 0 to pi by 2 into 1 into theta, then integral with respect to theta, that is theta, then a raised to 4 by 4 theta, where theta which is varies from 0 to pi by 2, then we can write a raised to 4 by 4 pi by 2 minus 0, that is upper limit minus lower limit. Then our answer will be pi a raised to 4 by 8, that is our answer of the double integral in polar coordinates, means converting to the changing to the polar coordinates. Exactly we have to find. Let's see one more example by the transforming into the polar coordinates. evaluate double integral 0 to a y to a x upon x square plus y square dx dy. Here inner limit which is dx form means inner limit which is indicated by the x, outer limit which is indicated by the y, means x which is varies from y to a and y which is varies from 0 to a. According to this limit we have to convert it into the polar form. Then firstly we have the x which is varies from x equal to y to x equal to a and y which is varies from y equal to 0 to y equal to a. Then we have the formula for the polar coordinates, x equal to r cos theta and y equal to r sin theta. Then firstly we consider the line, that is y equal to x. Then substituting in this equation where r cos theta and r sin theta, here r will be cancel out, then sin theta equal to cos theta, then cos theta which is comes denominator portion, then sin by cos, that is tan theta equal to 1, then making this subject as a theta, then theta equal to tan inverse 1, then theta equal to pi by 4. Similarly for the another equations of the line, that is x equal to a, then substituting the x equal to r cos theta equal to a, then cos theta which is comes denominator portion, then we can say that r equal to a by cos theta, then we can say that r equal to a sec theta, reciprocal of cos, that is sec theta. Now we have the angle in exact 45 degree, or obviously y equal to x line, that is line which is passes through the origin with 45 degree, which is infinite straight line. Now let's see, firstly draw the region in Cartesian coordinate and polar coordinate. In this polar coordinates and Cartesian coordinates we gave the same region, each and every example we gave the same region, whatever the shape which is in Cartesian coordinate, that shape exactly in form of polar coordinates, shape does not be changed. Let's see, firstly we have the equations of the line, that is y equal to x line, this is exactly passes through the origin infinite straight line up to this, an angle between x axis and y axis, that is 45 degree. X equal to a, that is vertical straight line which is passes through the P point, where position of P, that is a0, at O position, that is obviously origin, that is 0 0, and that is AA, that is our intersection point, and we have to double integral at that particular region capital R. Now converting to this region into polar form, then already we discussed x equal to y, then substituting the values of x and y as r cos theta, r sin theta, and simplified it, then we get the angular line which is theta equal to pi by 4, which is drawn here, that is the angle or infinite straight line which is theta equal to pi by 4. Here x equal to a, then that will give you r equal to a sec theta. Then we have to find this region. For that the polar coordinate system we have to angular straight line or a angular strip which is through the origin, that is our O position, and here our A position, that is the elementary radius vector which is OA. Now we have to finding the limit of r and theta. Then here at this position values of theta which is 0, and at this position values of theta which is pi by 4, means theta which is varies from 0 to pi by 4. Now this angular strip will be movement in this region, then minimum value which is touches to the initial line which is theta equal to 0, and maximum will be touches to the theta equal to pi by 4 line, means theta which is varies from theta 0 to pi by 4. Now another limit which is r, limit of r, here values of r, that is 0, at this position values of r which is a cos theta, means strip which is touches to the x equal to a and which is converted into the polar form, that will give you r equal to a sec theta. Then limit of r which is 0 to a sec theta. Then substituting this all the things in double integral, converting to the Cartesian to polar form, then hence the polar form of the given integral is I equal to double integral 0 to a integral y to a x upon x square plus y square dx dy. Here dx dy which is replaced by the r dr d theta, and our limit which is r which is varies from 0 to a sec theta, and theta which is varies from 0 to pi by 4. Now converting this term into the polar form, for that replace x as a r cos theta and x square plus y square as a r square. Then here r square which is cancel out. Then our integral becomes 0 to pi by 4, 0 to a sec theta into cos theta dr d theta. First integral with respect to r, then theta which is cos theta which is constant, then r 0 to a sec theta, integral of 1 that is r, then upper limit minus lower limit, then a sec theta minus 0. Here sec that is 1 upon cos, then cos will be cancel out, that will give you a which is constant comes out, then integral 0 to pi by 4 into 1 d theta, then integral of 1 that is theta, then upper limit minus lower limit, that will give you a into pi by 4 minus 0, then a into pi by 4. That is exactly we have to find. This is all about the topics of the change of variable from the Cartesian to polar coordinates. I hope you guys learn something from this video. If you like this video, then thumbs up. If you think that this video will help some of your friends, then do the share with them. If you want to watch more tutorial like this, then you can subscribe my YouTube channel, and whenever I upload the new video, you get the notification. If you have any query regarding this, then feel free contact me. Thank you so much for watching me.